As kids, and even as adults, we tend to look up at the night sky to see what lies beyond the atmosphere. With the naked eye, all we can really see are shiny, glittering blips of light that we call stars. Some of us even lay down on our roof or stare out of the window for hours, waiting to catch a glimpse of a shooting star, which are actually meteors. But that does not mean shooting stars don't exist. We've explained this a bit in this other video right here. Others try to count the stars in the sky, which may look like just a few thousand, but in reality, these too are millions in number. As glamorous as the twinkle in the night sky looks, truth be told, there's a lot more to what stars are than you or any of us understand. Over the years, through extensive research, astrologers have stitched together information that has helped define everything we know about stars today. You might be curious to understand these twinkles in the sky, how they form, their size, even how our ancestors have deciphered them in the past. The answers to those questions lie in this video, so keep watching Served Hot TV to find out. Let's begin by understanding what exactly a star is and how they form. Stars are basically large celestial bodies, a glowing hot ball of gas made of hydrogen and helium. It is these two gases that produce light and heat from the fission of nuclear material inside its core. As much pressure as this fission exerts outward, it is countered by the inward pull of gravity. This keeps the star balanced and regulates the force for most of the star's life. The process also creates enough light energy that escapes through the star's atmosphere in the form of light. This light travels through space at varied wavelengths, which reach planets like Earth anywhere between a few to millions of light years. But let's get back to the origin and understand how a star is born. No, we are not talking about the movie with Lady Gaga and Bradley Cooper. This video is only about the stars in space. Deep, deep space. There's a dense amount of dust clouds scattered through the galaxies in the universe. Known as nebulae, the clouds are hydrogen-based. An example of such a dust cloud is the Orion Nebula, also known as Messier 42. Stars form inside these clouds of dust and gas. Over time, this dust and gas inside these clouds are pulled closer by gravity. This increases the density of gas and dust, causing it to collapse in on itself. The collapsed gas cloud leaves behind hot, dense material at its center. The result? A protostar, which is the hot core at the epicenter of the dust cloud. This space cloudburst breaks up into 2 or 3 different clusters of material, which leads astrologers to believe that it forms more than just one protostar. Other dust material can render planets, comets, asteroids, or stay as dust. But this video is about stars, so let's stick to them. The protostar does not qualify as a fully grown, stable star. Once the protostar is born, it keeps spinning while the temperature rises until it enters the T-Tauri phase. T-Tauri stars are relatively young stars as compared to older stars. By young, we mean that as compared to the older stars, T-Tauri stars are only about 10 million years old. Millions of years after the initial 10 million, the core temperature of the protostar climbs to about 27 million degrees Fahrenheit. Nuclear fission begins, igniting the core, marking the beginning of the next stage in the life of a star, also known as its main sequence. The Sun, just like many other stars in our galaxy, are termed as main sequence stars. It means each of them exists in a stable state of nuclear fusion, converting hydrogen to helium and emitting X-rays. The entire million-year process emits tons of energy, which keeps the star hot and shiny. We'll get to what happens after a star has burned through its power source at the end of this video, so don't panic just yet. In the meantime, let's shed some light on the Sun and other stars discovered in the past. You may think that the giant red ball in our solar system is huge, but that's not true. Countless other stars are much larger than our Sun, but we cannot see them. The reason we can't see them is as simple as why a plane keeps getting smaller in the sky before it disappears. These stars are not just millions, but billions of light years away from our solar system. So, if we were to bet it all on plain logic, These stars are just too far away for us to see with the naked eye. On the other hand, astronomers have been able to detect stars with ridiculously large telescopes. These stars are much farther away from the Earth. But not all stars burn the same. Some burn brighter than the others. Hotter stars can appear white or blue, whereas cooler stars will have an orange or red color. Astronomers detect and plot these stars on a graph called the Hertzsprung-Russell diagram, which enables them to classify these stars. They are categorized as the main sequence, white dwarf stars, dwarfs, giants, and supergiants. Here are a few stars that are close to Earth and larger than the Sun. The first one is Sirius A, also called Alpha Canis Majoris A, the dog star. The star is about 9 light-years away from Earth and 2 times the size of our Sun. Aldebaran, that floats in a binary star system, is 65 light-years away and 52 times the size of our Sun. Rigel, the first of the supergiant stars, is 773 light-years away and 70 times larger than our Sun. Antares A, another red supergiant, is 600 light-years and 430 times bigger than our Sun. Finally, VY Canis Majoris, the largest star discovered by humans, is 4,900 light-years from the Earth and has a diameter of 1.7 billion miles. That's so huge that if this star was placed in our solar system, it would stretch further than Saturn's orbit. Our Sun is just 864,938 miles, 1.392 million kilometers, in diameter. So you can only imagine how much bigger these other stars are. While walking on one of these hot stars is difficult, getting there is too. There isn't any technology advanced enough to carry people to planets outside our solar system. That does not mean it won't happen someday. We've got our fingers crossed. But just because we can't get there yet, does not mean we have no use for stars. On Earth, stars have served many purposes, especially to our ancestors. They've been helpful to humans long before we were even born. Stars helped our ancestors figure out when to plant and harvest their crops. They even categorized and named constellations, of which many are still very much in use today. They use stars to tell stories about heroes and gods. They even use these lights in the sky to represent animals and mythological creatures. Some storytellers from ancient civilizations used stars to teach the young and old about their cultures, values, and the tribe's customs. Ancient sailors utilized stars to guide them at sea. The North Star, also known as Polaris in specific, helped thousands of travelers understand the direction of their destination. Some even believed that the movement of stars could help predict the future course of a person's life. But we're going to let that one slide. So, with all this information and uses about stars, what happens when it serves its purpose? What happens when a star is out of juice? Well, here's a simplified version of what happens then. You see, when it burns through most of its hydrogen, that is, when most of it converts to helium, the latter gas sinks to the core of the star. This breaks the balance the star once had in its main sequence, causing it to heat up more and the outer shell to expand. The star turns into a red giant and slowly begins to shed its layers. Keep in mind that all of this is still happening over thousands of years and not instantly. The layers keep shedding off until all that's left is a white dwarf. These white dwarfs then start cooling down for millions of years. Other stars, part of a binary system, could gather extra matter from the nearby stars until the surface explodes into a bright supernova. Some may even implode in on themselves, turning into black holes, a phenomenon we are yet to understand. Someday, millions of years in the future, even the sun will die out, either causing a massive explosion through the solar system or creating a black hole that sucks in anything close to it, like our planet. But you have nothing to worry about yet. We're sure by then, the human race would have found a way to move to other planets or even solve the sun problem. Maybe we could learn how to travel in time, like that series on Netflix, Dark. Or maybe the actions of the future. Yeah, now we're getting carried away. For now, that's everything we know about our stars.
Thank you for watching. If you like the video, hit the like button, and subscribe to our channel. Don't forget to press the bell notification icon to get latest updates.